Good morning, students. So we were doing atomic structure. In atomic structure, we were working with Bohr's theories. We learned saying that an electron revolves around the nucleus. And then I was telling you in the last class that if this is the nucleus, there are shells around the nucleus where the electrons rotate. The first shell is called the K shell. K shell is given n value equal to 1. Then you have L shell. It is given n value equal to 2. Then M shell. M shell you have n value equal to 3. Then you have the N shell. You have n value equal to 4. Further, like this it keeps going on. Further, we said that the number of electrons in any shell is given by the 2n square rule. That is the maximum number of electrons in any shell is given by the 2n squared rule. So according to that, there are 2 electrons here. According to that, there are 4 electrons here. There are 9 electrons here. There are 16 electrons here, and so on. Okay, there are 2 electrons, 4 electrons, 9 electrons, 16 electrons, and so on. It keeps, 16, 2n squared, right? So it is 32, 18, 8. So 2 into n squared, not just n squared, 2 into n squared. So 2, 8, 18, 32, and so on, right? So this is what we had seen in the last class. Further, I had told you a few other things. Number 1, that the maximum number of electrons in the outermost shell, don't have to copy, you can listen to me, in the outermost shell is 8. Okay, even though 2n squared refers to the maximum number of electrons that can be accommodated, but in reality the maximum electrons in the outermost shell is 8, right? So now what we will do is we will try to write down the electronic configuration for different elements. So what I will do is I will write down the names of the elements and their atomic numbers, and you are going to try to write down the electronic configurations. Okay, not just the electronic configurations, you will also tell me how many electrons are there, how many protons are there, how many neutrons are there. So you will also be doing that. Okay, so before I move on, let me just check if there are any messages for me. And what is the message? Sir, your voice is getting struck. Okay, do more of you experience that, or only one of you? I can't able to understand. Sir, can you say what we should write? I will tell you. Is my voice clear or not first? Okay, voice is clear, so don't worry. Yes, so here it is. So hydrogen has atomic number 1, mass number 1. Okay, so you have to tell me how many protons it has, how many electrons it has, how many neutrons it has, and the fact that 1 electron will go to the K shell. So in the K shell you will have 1 electron. So this is the electronic configuration for hydrogen. For helium, it will have atomic number is 2, mass number is 4. Now because atomic number is 2, how many protons will be there? 2. How many electrons will be there? 2. How many neutrons will be there? 2. And here, because there is only K shell, will have both the electrons. Okay, then we will go to lithium. Lithium has 3. So if it has 3, in the K shell you will get 2, maximum possible is 2. In the L shell you will have 1 more. Okay, so now lithium, what is the mass number for lithium? 7. Okay, you have to remember these till atomic number 40. Yeah, you have to remember these till atomic number 40. So lithium has 3 protons, 3 electrons. Mass number is the total number of protons plus neutrons. I will write it here. Mass number is equal to total number of protons plus neutrons. atomic number is equal to total number of electrons, which is equal to the number of protons. Okay, so now is it clear with what I am expecting from you? Yes, yes. First, is it clear or not? Yes. See, for some people voice is clear, some people voice is not clear, means it is your problem, not my problem. Because your internet may be little problem. So, or you may have to go to, no, what is not clear? What is expected from you is not clear. Okay, I will tell you again. So, I want you to write the electronic configuration for beryllium. Beryllium has atomic number 4 and it has mass number 9. So I want you to write the electronic configuration for beryllium. So the electrons go to the different shell, K shell. K shell has maximum of 2 electrons. Then after that they will go to the L shell. L shell has maximum of maximum of 8. So 2 is less than 8. So no problem. So K it will have 2, L it will have 2. How many protons does beryllium have? It has 4 protons. How did I say that? That is the atomic number. Then how many electrons does it have? 4. Number of protons is always equal to number of electrons. Then this is the total number of protons plus neutrons. That is the mass number. So how many neutrons will it have? 9 minus 4. So it will have 5 neutrons. How many neutrons are there here? 4 neutrons. So I want you to write this for all the elements. I will write down the elements. I want you to write this. Next one is boron. Boron has an atomic number of 5 and a mass number of 11. Boron has an atomic number of 5 and a mass number of 11. Okay, how to find the K shell? What part is not giving? You given homework as elements up to 40. I know, but I am not sure if you will write, because there are students who are also asking me how to find the K shell. Na? What do you mean by K shell? K shell is the first shell. First shell is K. So in the first shell, how many electrons can go? 2 electrons can go. Boron has 5 electrons. So first electrons will go to K. K, what is the maximum number of electrons in K? 2. Next, they will go to the L shell. In the L shell, how many electrons can you have? You can have up to 8. But how many are left here? 3. So 3 will go to the L shell. So 2 electrons go to the K shell and 3 electrons will go to the L shell. So this is the electronic configuration for boron. In that electronic configuration, there are totally 5 protons, 5 electrons, and there will be 6 neutrons. So this is the number of neutrons. This is the number of protons. Yeah. Atomic number is the total number. Please don't look at the handwriting. Please listen to what I am saying. Is the total number of electrons, which is equal to the number of protons. Mass number, mass number is the total number of protons, which is equal to the number of neutrons. Okay, so for each element that I give, I want you to write down where the electrons are going. Yeah, So I don't understand that question. How to find the K shell? I don't understand the question. K shell is the first shell. K shell is the first shell. L shell is the second shell. M shell is the third shell. KLM, N shell is the fourth shell. N shell is the fifth shell. Okay. First shell will have maximum of 2 electrons. Second shell will have maximum of 8 electrons. How did I get this? I get this by the 2n square rule. Third shell will have 18 electrons. That is 2 into 9. Fourth shell will have 32 electrons. That is 2 into 16. Fifth shell will have 50 electrons. That is 2 into 25. This is the maximum number that is ever possible. It can never, maximum number, it can never be more than this. Okay. Yeah. Where did I write 2 times N? KLMNO, MN. Please change. You work on all those things. Please don't just copy from the board. Okay, please don't copy from the board. If I write A is equal to like this, I'm sure you guys know that A is written this way. So you write A. Okay, so don't worry about it. Please don't copy from what I have written. Please apply your minds and then work. Okay, so that is the aim. Now, aim is not to write down what I am writing on my notebook. Yeah, so next one is carbon. Carbon atomic number is 6, mass number is 12. Okay, so please write down its electronic configuration. So how many protons, how many electrons, how many neutrons? Write that first. So this is the atomic number. So it will have 6 protons. Number of protons is always equal to number of electrons. Then this is 12 here. So 12 minus 6, it is 6. So this 12 is the mass number, MASS. NUMBER, mass number, is equal to number of protons plus number of electrons. I'm sorry. Number of neutrons. Mass number is equal to number of protons plus number of neutrons. Okay. Then next one is nitrogen. Nitrogen has mass number, atomic number 7 and mass number 14. Then oxygen has mass number 8, atomic number 8, mass number 16. After oxygen you have fluorine. Please write the names of the elements also. Fluorine has 9 and then it has 19. Yeah, so here in the K shell, K you will have 2. Then in the L shell, the rest will go 4. Okay, for nitrogen, it will have 7 protons, 7 electrons, and 7 neutrons. So here K shell will have 2, L shell will have 5. Okay, so please write down the electronic configurations of each. So number of protons in oxygen is 8. Number of atomic number is equal to number of protons. That is also equal to number of electrons. Then number of neutrons is 16 minus 8. 16 minus 8 is 8. So here K shell will have 2. Then L shell will have 6. Okay. Now I hope you are able to understand how to calculate the atomic mass. You cannot calculate, it is given. Atomic mass is the total number of protons plus neutrons. It will be given or you will have to memorize. Okay, up to 40 you have to memorize. You cannot calculate the atomic mass. Atomic mass is given. It is given. It is to be remembered. It is the total number of mass number, that is atomic mass number is the total number of protons plus number of neutrons. Atomic number is the total number of, is equal to the total number of electrons, which is equal to the number of protons. Atomic number. So here this is the atomic number, this is the atomic number, this is the atomic number, this is the atomic number for fluorine. Down what I am writing is the atomic number, up what I am writing is the mass number. That is the typical way to write it. Okay, so that is the typical way to write it. So for oxygen is over fluorine. Fluorine, this is 9, this is 9, this will be 10. Then K shell, there will be 2 electrons. L shell, there will be 7. What is 8 square? M. N square. N is the principal quantum number, not the number of electrons. So N is 2 into 3 square. 3 square is, yes, is called as the mass of an atom relative to mass of one atom of carbon 12 is called mass number. Shri Sai, I don't understand your question. Shri Sai Siddhartha, I don't understand your question. I'm saying that K shell is the first shell. Whenever electrons go, they will go to the first shell. Okay, so now the next one that I can write down after fluorine is neon. Okay, is neon. Neon has an atomic number of 10 and a mass number of 20. This is 10, this is 20, right? So if a neon has an atomic number 10, so number of protons is equal to 10. Number of neutrons will become equal to 20 minus 10, 10. Number of electrons will be 10. Okay, now always the electrons will first go to the K shell, then they will go to the L shell, then they will go to the M shell, then they will go to the N shell, O shell, and so on. So in the K shell, 2 can go. Okay, then how many more are left? 8 are left. So 8 will go here. Okay, so after that there is nothing else. So no more requirement. Yeah. So next one is sodium. Sodium is 11 here, 23 here. So sodium will have 11 protons, it will have 12 neutrons, and it will have 11 electrons. So in the K shell, 2 will come. L shell, 8. 8 is houseful, no more can come. So the next one will come to the M shell. So in the M shell, you will get 1 electron. Okay, so this is how it goes. Then next one is after sodium is magnesium. Magnesium will have atomic number 12. It will have mass number 24. Okay, it will have mass number 24, or to be more precise, it will be 25, but fine, we'll work with 24. So this is 12 here, this is 12 here, this is also 12 here. So 2 will come here, houseful, 8 will come here, houseful, then 2 will come here. Yeah, so it will have 2 electrons in the K shell, it will have 8 electrons in the L shell, it will have 2 electrons in the M shell. Why did I say L shell 8 is houseful? 8 is houseful because it can, any shell can have 2 into n square number of max electrons. So that will become 2 into 2 squared. 2 into 2 squared is 2 into 4. So 2 into 4 is how much? 8. So it will have 8 electrons max. Okay, so the moment 8 electrons come, it becomes houseful. I don't have electrons to go to MnO, no. So I have now electrons will always go from the innermost shell. They'll always fill from K shell. Okay, they will always go from the K shell. Yeah, the electrons will always fill up from this side. They will not go wherever they want to go. So this is what Bohr said. They will always fill up K first, then they'll go to L, they'll fill up L, then they'll go to M, they'll fill up M, and then they will go. So electrons always will go fill up in this order. Okay, so once K is over, Mg is over, the next one is aluminium. Aluminium is basically 13 here and 27 here. So the number of protons is 13, number of neutrons will be 27 minus 13, which is 14. Number of electrons will be 13. So here 2 will come here, house is full, then 8 will come here, house is full, then 3 will come here. Okay, so now aluminium is also done. Yeah, after aluminium, next is silicon. Silicon is 14 and 28. 14 and 28. So there are 14 here, 14 here, 14 here. So now what will happen? Now 2 will come here, 8 will come here, and 4 will come here. Yeah, so yeah, so this is also managed now. Yeah, next after silicon you have phosphorus. So you have phosphorus. In phosphorus you have 15 here, and this will be 30. Okay, more not 30, it will be 31. 31. So you have 15 here, you have 16 here, and you have 15 here. So it will become 2, 8, 5. So like this, keep writing. If you have doubts, I will clear. Okay. So am I clear? Yes. Okay. So yeah, so these are the electronic configuration of the different elements so far. Like this, we have to slowly go all the way up to 40. So please write the name of the elements. This is phosphorus, PHOS, PHEROUS, phosphorus. This is silicon, SILICON, phos, PHOS, phorus, PHOROUS, sorry, RUS, phosphorus. Okay. PHOS, PHORUS, phosphorus. Silicon, இது aluminium, ALUMINIUM, aluminium. Magnesium, MAGNESIUM, magnesium. Aluminium. Phosphorus. Sir, the screen is so close, please make it normal. Okay, so if this is done, then let us go to the next one. We have finished till phosphorus. Then is sulfur. Sulfur atomic number 16 and the mass number is 32. Okay, so K shell, L shell, M shell, N shell, like that you please fill number of protons, number of neutrons, number of electrons. Sulfur, then chlorine. Chlorine is 17 and that 17 is here, 35 is here. Okay, after chlorine is argon. Argon is 18 is here and 40 is here. Okay, after argon is calcium. I'm sorry, after argon is potassium. So you have potassium. Potassium you have 19 here and you have 39 here. Okay, 19, 39. Then you have calcium. Calcium you have 20 here, 40 here. Okay, so for each of these, please try to write it down by yourself. Okay, so number of protons 16, number of neutrons 16. Then number of electrons is also 16. Okay, so you have 2 here, you have 8 here, and you will have 6 here. For chlorine, this will be 17, this will be 17, sorry, 18, and this will be 17. Yeah, so now what will happen? 2 will come here, 8 will come here, 7 will come here. Then argon is 18, 40, right? So this will become 18, this will become 22, and this will become 18. So you have 2 here, you have 8 here, and you have 8 here. Okay, so now are we able to understand? Yes, so keep going, keep going. The next elements that we have are K, potassium. Potassium will have 19 here, it will have 20 here, and it will have 19 here. So 2 will come here, 8 should come here, actually 9 should come here. If not, because now in the M shell maximum capacity is 32, but Bohr said the maximum number of electrons in the outermost shell can only be 8, it can never be more than 8. So this will become 8 and 1 electron will come to the N shell. Okay, so now in calcium what will happen? You have 20 here, you have 20 here, you have 20 here. So this will remain 2, this will remain 8, this will remain 8, and this will become 2. So that now you see, yeah, so now this is the way it will keep going on. Okay, according to Bohr, the maximum number of electrons in outermost shell in outermost shell cannot exceed 8. So if you put 9 here, it is becoming more than 8. So that cannot be there. So it will become 8 here and then 1 here. Okay. Saksham, I don't understand. Sir, in N argon 2,1, sir. What is the 2,1, sir? Argon, this is 40, this is 18. So 18, so it has to be 22. Okay, so number of neutrons is not 21. How can it be 21? 18 plus 21 is 39. But we are writing that it is 40. If mass number is 40, I agree there are some isotopes. There are some isotopes which will have 39, but argon is 40. Okay. Yeah. The number of neutrons is not important. Don't worry. Don't waste your time on that thinking. Yes, in some books argon is given as 39. In some books argon is given as 40. Argon has different isotopes. One isotope is 39. One isotope is 40. The more predominant isotope is the 40 isotope. Okay, so this is more predominant. This is more predominant. This is more predominant. So if you are reading some book where it is given argon is 39, it's not wrong. That is also fine. You write 21. I have no problem. But this our electronic configuration will not change because of that. Okay, so I'll continue to write what is given in my book or what I have learned. So not a problem. Yeah, after calcium is over, you have scandium. Scandium, Sc. Sc is basically 20 and 40. 20 and 40. So that is a predominant isotope. Okay. Sorry, 20 and not calcium is 20 and 40. It is 20 and 45. 45. That is a predominant isotope. Then you have titanium. Titanium has 22, yeah, 22 and 48. After titanium, you have vanadium. Vanadium is 23 and 51. 23 and 51. After vanadium, you have chromium. Chromium is 24 and 52. After chromium, you have manganese. Manganese is 25 and 25 and 55. Okay, so I want you to write the p value, that is the number of protons, then the e value, the number of electrons, and then the n value, the number of neutrons. Then I want you to tell me in the K shell, L shell, M shell, N shell, O shell, so on, how many. So scandium, I wrote 20, I'm sorry, it should be 21, 22. So scandium is 21. So if scandium is 21, number of protons is 21, number of electrons is 21, number of neutrons is 45 minus 21, that is 24. So here 2 will come, then 8 will come, then 8 will come. So this is 18 and then 3 will come. Okay. Now titanium here 2 will come, 8 will come, 8 will come, then 4 will come. Then vanadium, here 2 will come, 8 will come, 8 will come, 5 will come. Then chromium, 2 will come, 8 will come, 8, 6. 6. So 10, 14, correct. Then you have manganese. Manganese, you will have 2 here, 8 here, 8 here, and 7 here. Okay, so let us fill these up. So you have 22, 22, 22, 22, 26. Then vanadium, you have 23 here, 23 here. So 51 minus 23. So 51 minus 23 is 28. Chromium is 24 here, 24 here. 52 minus 24. 52 minus 24 is like 28. So this is 25 here, this is 25 here. So this is 30 here. Okay, so I have filled up in each shell. Okay, yeah, I will show. Yeah, I forgot 21, I added it. Yeah, atomic number 21. Yes. So please don't copy what I am saying. Instead, apply your minds and keep doing it. Good. So here the slide is done. So I will show it for some more time so that it will help those of us who want to. Yeah, up to atomic number 40, you all should commit it to memory. So after manganese is iron, cobalt, nickel. Okay, so if this is understood, then let me go to the next shell. So next is iron, cobalt, nickel. So you have Fe. So Fe is basically 26 and 56. Then iron, then cobalt is 57 and this is 59. Then you have nickel. Nickel is also 59 but 28. Oh, this is 27, not 57, 27, 28, and this is 58. Okay, after nickel, you have gallium. Gallium is basically 30, 20, what am I doing? Iron is 26, cobalt is 27, nickel is 28, then copper, not gallium, copper is 64 and this is 29. Okay, so I want number of protons, number of neutrons, number of electrons, then I want number of electrons in K shell, L shell, M shell, N shell, O shell, P shell. So the number of protons here is 26, this is 30, this is 26, 2, L shell 8, M shell 8. So 10, 18, and now this will become 8. Okay, so M shell is 8. Okay, then cobalt is like 27, then again it becomes 32, and then again it is 27. So it is 2, 8, 8, and this will be 9. But look, now there is a problem. Now here, this is not the last shell. Because this is not the last shell, now this will become 9 and this will remain 8. Okay, this will become 9, this will remain 8. In case of nickel, this is 28, 28, this is 30, this is 28. So 2, 8, 10, and then will come 8. So now this is 28. Okay, now this is not the last shell, this is the last but one shell. So according to Bohr's model, the last but one shell can have a maximum of up to 18 electrons. So now it keeps going. Okay, so now copper is 29. This will become like 35. This is 29. So it is 2, 8, 11, and 8. 2, 8, 11, and 8. And it keeps, now we keep increasing we don't add the final electron to the last shell, but we add it to the last but one shell. Okay. Yeah. I will show you, but I don't like the idea of taking screenshots. You have to work. Cobalt, rhodium. Okay, many people have remembered. No problem, no problem. Keep doing this. Keep doing this up to atomic number 40. Keep doing this up to atomic number 40. The next of the rest of the elements, I will do it little fast so that we are clear. So next is zinc. So zinc has an atomic number of 30. Okay, then you have gallium, 31. After gallium, you have germanium. Germanium is 32. After germanium, you have arsenic. Arsenic is 33. Then you have selenium. Selenium is 34. Then you have bromine. Bromine is 35. And then you have krypton. Krypton is 36. After krypton, you have potassium. After krypton, you have rubidium, Rb. Okay, Rb is like 37. After rubidium, you have strontium. Strontium is Sr. Sr is 38. Okay, so now here in the K shell, K, L, M, N, O. So in the K shell, you have 2, you have 8, you have 8 here, and this is 10, 18. So you will have 12 here. Okay, and then in gallium, it becomes 2, 8, 13, 8. In germanium, it becomes 2, 8, 14, 8. In arsenic, you have 2, 8, 15, 8. Then selenium, you have 2, 8, 16, 8. In bromine, you have 2, 8, 17, 8. Now you see this is filling up. The maximum in M is how much? 18. So in case of krypton, it becomes 2, 8, 18, 8. Now you see this is full, this is full, this is full, this is also full. So now when you go to rubidium, it will become 2, 8, 18, 8, and then O shell will now start getting electrons, because if this gets electrons, then what happens? The outermost shell can never have more than 8 electrons. So now that rule is getting violated. And here also the last but one shell can never have more than 18 electrons. So it goes out. So now it becomes 2, 8, 18, 8, 2. And then now again it increases. Now all the electrons are going to the O shell. Okay. So I hope this is clear. Yeah. So if this is clear, yes, yes, yes. Yeah, so finish it. And now we can go up to 40. The 39, this will become 3, 40, this will become 4. 40 is zirconium and yttrium. 39 is yttrium. Okay, so if it is done, then we are happy and we will move. Okay, so to all of you, I hope it is clear. If it is clear, so once last, I will write a few statements there. So first, an electron revolves around the nucleus in fixed circular orbits. Yeah, an electron, please don't tell me handwriting is bad, no problem, you write it down, I am dictating. An electron revolves around the nucleus in fixed circular orbits. These orbits have fixed radius and energy. These orbits have fixed radius. This is the Bohr-Bury structure of a model of an atom. We am revising it from the beginning. This is the Bohr's model of an atom. Bohr model of an atom. Okay, an electron revolves around the nucleus in fixed circular orbits. These orbits have fixed radius and energy. As long as an electron remains in an orbit, it neither gains nor loses energy. As long as an electron remains in an orbit, it neither gains nor loses energy. Okay, then it can absorb a fixed amount of energy and jump to a higher orbit. Okay, it can absorb a fixed amount of energy and jump to a higher orbit. Okay, higher orbit. This is called an excited state. This is called an excited state. EXCITED, excited state. This is called an excited state. Okay. Sir, Bohr is a scientist only. Yes. 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 Sir, by 2n square, K has 2, L has 8, M has 18. Yes. Yes. Okay. So now, if this is clear, this slide is clear. An electron, first one, an electron revolves around the nucleus in fixed circular orbits. Okay. Second one, these orbits have fixed radius and energy. Fixed means what? Okay. So what are we saying? Fixed in terms of radius. That means they will have a specific radius and they will have a specific energy. Then as long as an electron remains in an orbit, it neither gains nor loses energy. Please understand, this was the problem with the planetary Rutherford's model of an atom. They said an electron is going to give energy. Now Bohr said, look, I don't know why, but an electron will neither give energy nor take energy. Now, if it takes energy, it can jump to a higher orbit. Now, if an electron from its original step goes to a new shell, a new radius, a new circle, then it is called the excited state. This is called the excited state. Okay. Then let me check if there are any questions. is both a chemist and a physicist, is more of a physicist. I didn't, see, again and again I am explaining to you, Rishi, I said what you have written, that is a maximum number. Okay, let me come back to that. I said that is a maximum number. What is no? No, no, yes. What is no? Are you able to hear? Not able to hear? Yes, friends, are you able to hear? Not able to hear? Oh, no means no doubts. Okay. Seri. Rishi Nana solla varena. Can hear, able to hear. Okay. What I am trying to tell, please understand. I am saying that, let's come back to that slide. Yeah, I am saying that in the M shell, the maximum number of electrons is 18, no doubt. But the moment this happens, then in the outermost shell there will be more than 8 electrons. So that cannot happen. So in the outermost shell there cannot be more than, so it comes to the inner shell. That is what I am trying to tell. This is not the point. This is the, before this is the point. Here is the point. Now in potassiums, because M can accommodate 32, if this comes here in 9, then this will not be there. Then outermost shell is having more than 8. This is not possible. The outermost shell can never have more than 8 electrons. So this will have 8 and this will have 1. So 1 will go there. Now about that 18, yes, here it is going. See, now this is okay. Now you see the number of electrons are increasing. So I didn't say M will have only 8. So I said M will have good number, 2, 8, 18. So here it has increased. Only after this M has got 18, now the next electron cannot come here. Though N can carry 32, it cannot come here. Why it cannot come here? Because it should have 9, it will have 9 electrons, not possible. Maximum number of electrons in the outermost shell is only 8. So 1 will come here. Okay. Okay, so okay, so you guys are understanding. Ayyo. Seri, okay, in the page, I hope all of you are able to understand this page. Okay, that it can absorb. Now 5, the electron can come back to original orbit by giving the same amount of energy. Okay, then the maximum number of electrons in any orbit is given by 2n square rule. So K shell will have 2, L shell will have 8, M shell will have 18, N shell will have 32, O will have 50, and so on. This is the maximum number. Maximum number doesn't mean so many are sitting. Okay. Then the maximum number of electrons, in outermost shell is 8. The maximum number of electrons of electrons in penultimate shell. Pen means last but one. Penultimate shell is 18. Okay, so we have to remember this. When we are fixing the number of electrons in the outermost shell, we have to remember this. The maximum number of electrons in the outermost shell is 8. The maximum number of electrons in the penultimate shell is 18. Okay, so based on this, we have written all our electronic configurations. Okay, so this is slide 1. This is slide 2. This is slide 3. This is slide 4. This is slide 5. Next one. Next one. I'm almost done with this chapter. Next chapter, next class, I will just discuss questions and we are done with this. Up to element 40, all of you should remember. (11) 12, 13, 14. Okay. No, I will give you test. I will give you test up to slide 1. Okay, octet rule is only stable. Then how come there is more than 8 electrons? So Subbalakshmi is asking, octet rule is only stable. So now, if we have to look at all these and find out which are the ones which are most stable, yeah. So only those, it is wrong to say that only those which have 8 electrons in outermost shell are stable. Only those elements which have 8 electrons in outermost shell and completely filled inner orbitals are stable. I will write it here. Only those elements which have 8 electrons in outermost shell and completely filled inner shells are stable. Only those elements which have 8 electrons in outermost shell and completely filled. This is very, very important. So krypton is completely filled. This is not filled. So they are not stable. Then none of these are filled. So they are not stable. Coming back here, none of them are filled. So they are not stable. None of these are stable. Now this one, complete 8 electrons in outermost shell. This is full. So this is stable. Then coming back, none of them are stable because they don't have 8 electrons also. Now none of these are also stable. After fluorine, yes, neon 2,8 full, so that is stable. Okay, then helium full, so that is stable. So only those which are full are stable, otherwise they are not stable. Okay. Yes. Bromine, again next class I will explain. Yeah, slide 13. Okay. Okay, slide 1. Slide 1, there is nothing, I think. 1. ரமேஷ் நம்ம 12th டெஸ்ட் ஏதோ தப்பா இருக்கு சொல்றாங்க. மேத்ஸ் கெமிஸ்ட்ரி சிலபஸ் தப்பா வருது சொல்றாங்க.
Hello, sir. Okay, thank you. The class is over. Next class is at 2 o'clock, 2 to 3. Okay. Thank you.